Hi, everyone. Welcome to this webinar. Today's topic is on Amazon Lightsail containers or cloud containers made easy. My name is Jerry Hargrove. I am the Lightsail developer advocate. During today's webinar, I'm going to cover really three things. I've separated it out into three parts. First, I'll set the stage by giving you a brief intro to Lightsail, where it came from, what the design principles were for it. Then I'll move on to really the topic of this webinar, Lightsail containers. Now that you have some context, we'll cover containers and what it's about and how it was designed. And finally, I'll close by demonstrating really just how easy it is to use Lightsail containers to run your containers in the cloud. I think at the end of this webinar, you'll have the information that you need to start using and experimenting with Lightsail containers yourself. So with that, let's get started. Amazon Lightsail is a virtual private server, or VPS for short. Lightsail provides you with the compute, storage, and networking capacity that you need, and it provides you with the capability to deploy and manage your websites and web applications in the cloud. Lightsail is really the easiest way to get started on AWS for developers, for small businesses, students, or other users who need a solution to build and host their applications in the cloud. Lightsail is ideal for simpler workloads, quick deployments, or for someone who's getting started on AWS. It's really designed to help you start small and then help you scale as you grow. Lightsail makes it easy to get started in the cloud by automatically configuring networking, access control, security environments, and really taking the guesswork out of launching your server. And as your ideas grow, a Lightsail load balancer or databases or content distribution networks can easily handle your increased traffic and heavier workloads. Plus, you can use the full force of AWS, other AWS services, by connecting your project to other AWS services. Lightsail comes with very predictable pricing, and we do that by providing services in the form of a bundle. Lightsail plans include a virtual server with a fixed amount of memory, with compute, with SSD-based storage or disks, and has a free data transfer allowance. Lightsail plans also offer static IP addresses and DNS management for you to use, and you're charged on an hourly on-demand basis. So for your Lightsail instance, you only pay for it when you're actually using it. Lightsail offers a number of pre-configured one-click-to-launch application or developer stacks. You can launch a vanilla Linux operating system like Ubuntu or CentOS or Amazon Linux, or you can launch a vanilla Windows instance and install and configure your own applications to your own specification. Or you can pick a blueprint that is prepackaged with common applications like WordPress or LAMP or Drupal or Node.js, all of these designed to get you up and running in just a matter of minutes. But Amazon Lightsail is more than just a VPS, though. As I mentioned previously, as your Lightsail needs grow, we've provided a host of features to help your Lightsail experience grow with you. And that includes databases, content delivery networks, load balancers, DNS management, and the topic for today, containers. So let me talk briefly about a few of these before moving on to containers. With Lightsail, you can launch a fully configured MySQL or Postgres database in minutes and then leave all the maintenance and management to Lightsail. You might want to do this to scale your databases independent of your virtual private servers. You might want to do this to improve the availability of your applications, or you may just want to run a standalone database in the cloud. You can also use Lightsail databases to help deploying multi-tiered applications all within Lightsail and create multiple instances that connect to a centrally managed database. You can also then use a load balancer to direct traffic to those instances. Lightsail managed database plans bundle together memory, processing, storage, and transfer allowance into a single predictable monthly price, just like Lightsail VPS servers. As I mentioned, you can also load balance your applications in Lightsail. Lightsail provides a simplified load balancing solution that routes web traffic across your instances so your websites and applications can accommodate variations in traffic. They can be better protected from outages, and they can deliver seamless experiences for your visitors. Included with Lightsail load balancing is certificate management, which provides you with free SSL and TLS certificates that you can provision and add to a load balancer in just a couple of clicks. You can request and manage those certificates directly from the Lightsail console, and Lightsail manages the renewal of those certificates on your behalf. So very quickly, you can, in just a couple of clicks, start handling HTTPS traffic, and you have the ability to very easily add and remove instances from your load balancer. In addition to managed databases and load balancing, you can also use Lightsail's content delivery network distributions to help scale your application out. They make it easy for you to accelerate the delivery of content hosted on your Lightsail resources by storing and serving it on Amazon's global delivery network that's powered by Amazon CloudFront. These distributions can also help you enable your website to support HTTPS traffic by providing simple SSL certificate creation, hosting, and management, similar to what was mentioned with load balancers. And finally, these distributions can help reduce the load on your Lightsail resources and can help your website handle large traffic spikes. And like the other Lightsail features, you can set these up in just a few clicks, and you pay a simple monthly price for this. One of the features of Lightsail's content distributions that I really like are preset configurations that come with it, including one for WordPress. You can create your distribution, select your WordPress instance on Lightsail as the origin, and you're all set. The Lightsail distribution automatically configures so as to optimize performance for WordPress. It's really great. In addition, you can add additional block storage to your Lightsail instances. Each Lightsail bundle includes its own SSD storage, but there are times when you need more disk space. Lightsail block storage provides additional storage volumes or disks that you can then attach to your Lightsail instance. It's similar to another hard drive. It's very useful for separating your application data from system data, for example, the OS from the software or the application data, and it allows you to do independent backups and snapshots to further protect that data. And these block storage instances use SSDs, providing a good balance of price and performance. As your cloud ideas expand, you may need more, and we provide an easy way for you to access other AWS services from Lightsail. You can integrate your Lightsail project with some of the other 90+ services available on AWS through Amazon VPC peering. You can manage those services in AWS using the AWS Management Console while you still keep your day-to-day management in the Lightsail console. You kind of get the best of both worlds doing that. And as your cloud ideas expand, you can very easily move to EC2 with a simple guided experience. Upgrading to EC2 offers you really the comfort of knowing that as you grow your website or your application, you can scale in a way that really fits your needs and the maturity of your application. And it's simple. You take a snapshot of your instance, follow the step-by-step process in the Lightsail console to export your snapshot to EC2, and then you can run the upgrade to EC2 wizard to get a new EC2 instance up and running very quickly. So to close out the introduction to Lightsail, I wanted to talk about a couple of popular workloads that are run on Lightsail. First are simple web apps, so you can really easily deploy a web application with just a few clicks. You can use pre-configured development stacks like LAMP or Nginx or Mean or Node.js to really easily get your web application online. You can really quickly create websites that really shine. You can create and customize your blog, e-commerce, or a personal website with Lightsail's pre-configured applications like WordPress, for example, or Magento, or Plesk, or Joomla, whatever you may happen to be using. You can also run your business software on Lightsail. You can run open source or commercial software very easily. Lightsail really helps you launch like line of business software like file storage and sharing or backups, or financial or accounting software, and much more very easily. And one of my favorite uses of Lightsail is for my dev and test environments. I can spin up a dev environment in just a matter of seconds. I can create myself a dev sandbox or a testing environment outside of a production environment that lets me work in without concern of breaking something in production. And once you're done, you can then quickly destroy these instances. So with that, I want to close out the Lightsail introduction and move on to sort of the core of this webinar, which is Lightsail containers. Lightsail containers are a feature of Lightsail that were introduced at AWS reInvent in 2020. They're an easy way to run containers in the cloud. At AWS, we've really taken the best practices and common use cases to produce a simplified container experience that allows new cloud users, for example, to very quickly run containerized applications in the cloud, and to do so at a very predictable price. That sounds familiar, right? That's because Lightsail containers were designed using the same core principles of Lightsail: simplicity, ease of use, and fixed predictable pricing. And they're built using the same reliable AWS services like Elastic Container Service, Fargate, ECR, Elastic Load Balancing, and Route 53. So when we talk about Lightsail containers, we're really talking about Lightsail container services. And you can consider a container service really a compute resource. And that compute resource is located somewhere, and it has a certain capacity. And we deploy containers to those services, and those containers are made of familiar Docker images. So let's familiarize ourselves with Lightsail container services by talking about each one of these briefly. First is location. Container services are located in the same AWS regions as Lightsail itself. And like when you choose a region to launch a Lightsail instance, you choose a region for your containers similarly by asking yourself questions like, who's going to be using the container service? Where will the customers of this container service be located? Does the container service need to run in a certain geography? Do I have any data sovereignty concerns? Once you've decided where to locate your container service, then it's time to decide what your capacity requirements are. Capacity on Lightsail containers is determined by two things: power and by scale. The more power and scale you have, the more capacity your container service will have. The power of your container service is defined by the size of the compute node you choose. For example, here you'll see on your screen, I've chosen a small node size, one that includes 1 gig of RAM and a half of virtual CPU. If I wanted more power, I could choose a large node size, which, as you can see, includes 4 times the power of the small node, or 4 gigs of RAM and 2 virtual CPUs, and so on. You can see also that as you increase the power of a node, the cost of that node increases. More power, more cost. Less power, less cost. Makes sense. The scale of your Lightsail container service is determined by the number of nodes you choose. In this case, I've chosen to launch my service with 2 nodes, meaning I'll have twice the capacity as I'd have with a single node. The scale of your container service not only helps determine capacity, but also the resilience and availability of your container service. The more nodes you have, the less impact the failure of a single node will have on your service overall. If you have just a single node, or a scale of 1, this is considered a single point of failure. If that node fails, your service fails with it. You can also change the power of your container service once it's been created. When you do so, the nodes powering your service will be replaced with no downtime to your container service, ensuring your customers still have a happy experience. Changing the power of your container service is considered vertical scaling, or making your box bigger. You can increase the power of your service or decrease the power of your service as your needs dictate. You can also change the scale of your service after creating it, and can seamlessly add or remove nodes as you need to. This is considered horizontal scaling, or adding more boxes. For example, if you knew that your service was going to need extra capacity for a planned event, you could increase the scale of the service before the event to accommodate the increased traffic, and then decrease that scale back to normal levels once the event had passed. You can do all of this quickly, creating a Lightsail container service through the Lightsail web console, or you can also use the AWS command line interface, or CLI for short, to do the same thing. Here's an example of creating the container service in the web console on the left, and the equivalent command line command and parameters to do the same thing from the command line. I'll be demonstrating both of these here shortly. As a matter of fact, before I move on, let me demonstrate how easy it is to create a Lightsail container service. So I'm going to switch to my console. And here we are at the Amazon Lightsail console. I'm on the Instances tab. I'm going to switch to the Containers tab. And like any good webinar cook, I have some pre-cooked demos for us later on. But right now, I'm going to show you real-time how to create a container service. So as I mentioned, there are really two things that you need to know: where you want to create it, which region to use. So here, I'm going to choose Oregon because I'm in Southwest Washington, and that's the closest region to me. So that reduces the latency between me and my container service. And for a container service capacity, I'll use the default here. It's a micro instance. It'll cost $10 a month and is sufficient for the webinar that we're going to do today. You can also create a deployment through this UI as well, but we're going to skip that for now. I'm going to give my service an easy to remember name, like webinar. And you can see what the default domain is going to look like. It's going to be webinar and some random GUID that we can then use later to see our container service. With that, I verify all the settings that I've created and then click on Create Container Service. Now that might take a minute or two. It won't take very long, but we'll switch back to the presentation and I'll continue from there, and then we'll come back and take a look at this. So now that we've talked about container services themselves, let's talk a little bit about deployment. We've talked about where our container service is going to be and what capacity it's going to have. Now let's talk about how our container service is going to do that work. And that's in the form of deployments. Deployments are associated with Lightsail container services and define the containers in the service and how they interact with one another and how they interact with the outside world. An individual deployment is composed of one or more containers, up to 10. And if you worked with containers before, these are likely familiar concepts you see on the screen. A container service deployment has a unique name, one that you might choose that's easily recognizable. You might see it in logs later on, or when you're managing your container service deployment. In this case, I've chosen Nginx because I'm going to be deploying an Nginx web server. I could also call it web server, or I could just call it web, whatever helps me remember what it does or what it is. In addition, you need to provide the Docker image that you're going to be using for this. Where's the image located? Is it in a public repository on Docker Hub, or was it uploaded to the Lightsail container service itself? This can be an image that you've built yourself, or a public image like the master Nginx image, for example. And we'll see an example of what these two references look like later during the demo. On your screen here, I'm referencing the master Nginx container image located on Docker Hub. In addition, when you configure a container in a deployment, you can specify some optional parameters. And this depends on what your container requirements are. For example, you can provide a launch command to run a particular script or some other executable and provide some command line arguments for it. Or you can specify environmental variables that your container uses at runtime. These are key value pairs that you can use to provide runtime config information for your container. In this example here, I'm specifying a host name and a port for a downstream service that the container uses during its operation. In addition to launch commands and environmental variables, you can also specify open ports for your container to listen on. You can specify one or more open ports and the protocol that that port uses. In this case, I'm showing that my Nginx container will be listening on port 80, the standard HTTP port. But you can also specify other protocols and ports like HTTPS, or you can specify that your container service is going to be listening for UDP or TCP traffic on specific ports. These ports are then exposed by Lightsail Container Service and are reachable by other Lightsail container services. These parameters like name, image, command, variables, and ports can all be specified when you create a container service deployment using the Lightsail console, and you can also do the same thing using the AWS command line interface. And here's an example of a deployment configuration that includes multiple containers. In this case, there's an Nginx and Flask container, and shows how configuration options like ports, environmental variables, and commands are specified in this JSON file. When you create a deployment, you can also specify that it is publicly accessible through the default domain of the container service. And to do so, you pick one of your containers that exposes a port that you'd like to act as that public endpoint. When traffic is routed to the default domain, the container service will route that traffic to your container, and your container will then be able to handle that request and return a response. The container service also monitors the health of that endpoint via a health check path that you can specify. And like the containers themselves, you can specify the endpoint configuration via JSON configuration file. As you can see here on the screen, I'm going to use that Nginx container as the entry point into my service, and it's listening on port 80. So Lightsail Container Service will route traffic to the custom domain to port 80 on my container service. So this wraps up deployments. Pretty straightforward. Let's move on to images now. Amazon Lightsail Container Services use Docker container images in deployments to launch containers. You can use either a container image in a registry like Docker Hub, or you can build your own custom images and push them to Lightsail using the AWS CLI. And in just a few minutes, I'll demonstrate using both of these techniques. Docker containers are built using Docker files like the one seen here. If you've worked with Docker previously, this is pretty familiar to you. So with that, I hope this was a useful introduction to Lightsail containers. As you've seen, it's a simple way to deploy containers in the cloud. Now I want to move on to the demonstration portion of this webinar and show you just how easy that is. So during the demo section, I'll walk through some of the more common scenarios that you'll likely see when you're deploying containers to Lightsail. I've already shown how to create a container service and how easy it is. So next up, I'll show you how to deploy a public container to the newly created service. After that, I'll demonstrate how you can deploy your own container, building it first and then pushing it to Lightsail. And finally, I'll show a container service with multiple containers and how they interact with each other. So let's get started. So for this, I'm going to demonstrate how to deploy a public container using the console again. So let's go back to the console. And as we can see now, the service that I created previously is now ready. The status is ready and it's ready for a deployment. So I'm going to go here to the current deployment and select create first deployment. As I mentioned previously, there are a couple of required parameters when we create a deployment. The first is the container name. In this case, I'm just going to call it web. And the image I'm going to use is the public master Nginx image. And I can do that just by specifying the name of that image here, the identifier for it, Nginx. That's enough that Lightsail Container Service knows it's on Docker Hub, and it will grab the latest version of the Nginx image. I don't need a launch command for this, nor do I need environmental variables, but I do need to open a port. The Nginx container listens on port 80 for HTTP traffic, so I'm going to add that here. I'm only going to have a single container in this example, but as you can see, you can add more containers depending on your application. I am going to specify a public endpoint, though, because I want us to be able to visit that custom domain and actually see the output of the Nginx master container. So I'm going to specify that my public endpoint is going to be the web container, and it will pull in the parameters associated with the ports that were open for that container. In my case, I only opened port 80. If you had more ports open, you would choose which port you wanted to use. And I'm going to use the default health check path. That's all I need to do to deploy a container from a public repository. With that, I'm going to save and deploy it, and we'll see that its status has changed to deploying. So I'm going to go to the service that I created prior to the webinar, and we can see the output of that. As you can see, it has the same configuration as the one I just created. It's using the public Nginx image. It's listening on port 80, and I've created a public endpoint for it. So now if I visit the public domain for this container service, it's going to route that request to the Nginx container that I just created. And when I click on that link, my browser opens another window, and we can see this is the default output of the public Nginx container. Pretty simple and straightforward. So the second demo I want to show you is how to deploy your own container. And for that, we're going to go to a dev environment that I've created for this and create another web server, this time using Flask, the Python web framework. And the application itself is really simple. I have a single app route. And so when anybody hits that app route, it's really just going to return this HTML that I've specified up here. You can also see that when this application runs, it's going to listen on port 5000. The Docker file for this container is very simple. It's based on an Alpine Python image, so it's very thin and not very large. You can see that it listens on port 5000. When the container image is built, it's really just installing dependencies of the application itself. And again, the command that's going to be run when this application is run is the app.py. With that, what I'm going to do is I'm going to build this image. I built this previously, so this should go very quickly. And then I'm going to push this image up to the Amazon Lightsail container service that I created previously. So instead of pulling this image from a public repository, it's going to be located in Lightsail itself. So with that, I'm going to use the AWS CLI push container image command. I specify the webinar service name that we previously created. I'm going to push this image up that we just created, the Flask container image, and I'm going to label it Flask container. Pretty straightforward. So we'll go ahead and start that. It'll take just a second to push this up. The one thing that I wanted to call out here is the output of this command, and that's this label here. This is the label that it's applied to this container image in the Lightsail container service. We're going to need that in just a minute. So let's go ahead and copy that. And I'll switch back to the console. Now, if we go to our webinar service that I created earlier, it's actually up and running. And we can see that the public endpoint and configuration is similar to the other one. Now, I want to make a modification to this. I want to deploy a different container there. So I'm going to choose to modify my deployment. And I'm going to keep the same container name, but I'm going to change the image. And I'm going to specify that it's an image that is located in the container service itself. So I'm going to paste the label that I received as output from the command I ran from the command line. Configuration, I don't need anything there. I do need to change the port because Flask by default listens on port 5000. So I'm going to change that port, and the deployment automatically will update the public endpoint. I don't need to change anything there. It's still going to listen. It's going to use the default health check path and will listen on port 5000. So with that, I'm going to save and deploy this. So you can see here, deployment versions are maintained. You can go back later on and roll back to a previous container deployment version. Like for example, this was the first one. If this wasn't deploying right now, I could actually modify and redeploy it. If I go back to the container service itself, I can see that that container image that I just created and labeled is now part of the Lightsail container service, and it will stay with the container service. You can delete them as you see fit. If you ever delete the container service, it will delete any deployments and images associated with that. So while we're waiting for that to deploy, let's go back and look at our services that I created previously. It has the same thing. I just named it a little bit differently. Listening on port 5000, public endpoint is on port 5000. And if I go to the public domain now, we should see that simple message that our Flask container is emitting. And there it is. Welcome to Amazon Lightsail. So that was it. Pretty simple to set up and configure your own container for deployment. So for the last demonstration, I'm going to show how to deploy multiple containers. So I'm going to go back to my dev environment, and this is a slightly more complex environment. Here we have an Nginx. We've got two containers in the service. One is an Nginx container that acts as a reverse proxy. I'm going to call that the web container, and I have an app container that contains Flask. And these look very similar to what we saw previously. For example, the configuration for the Nginx container, instead of just doing the default behavior, it's going to act as a reverse proxy. Any requests that it gets in, it's going to send to the Flask server. And I'm going to specify the Flask host and Flask port via environmental variables. And we can see those here in the containers JSON configuration file. Here I'm specifying the Flask host and Flask port. This variable tells Nginx to do replacement in the configuration file with these values. The application file itself, the Flask container, is again very simple. When it receives a request, it will return this HTML snippet here. I've customized it so we can see it's part of the multi-container demo. It's doing exactly the same thing as the previous demo. It is going to be listening on port 5000 and will respond to requests there. I'm also going to configure the public endpoint, and I'm going to use the container name web. That's the Nginx front end, and it's listening on port 80. So I'm going to do all of these via the command line this time, and then we'll go to the console and see the results of it. So the first thing I'm going to do is build the Flask container, and then I'm going to push the Flask container to the Lightsail container service. And as I did previously, I'm going to grab this label for the Flask container service, and I'm going to go back to the containers JSON file, and I'm going to update this value right here, specifying which container version, image, and version to use. Then I'm going to go and I'm going to create the Nginx container. I'm going to build that, and then I'm going to push that one to the container service as well. And then when that's done, I'm going to grab that label as I did previously. I'm going to copy it here. And then I'm going to go up here and update this label. And I'm going to save that file. And then I'm going to actually deploy this container service from the command line. So instead of going through the console, the UI, I'm going to use the AWS CLI. So I'm going to use the create container service command, specify the container name, its webinar. I'm going to specify the container configuration file, containers.json, and I'm going to specify the public endpoint file. I'm going to create that. It will only take a brief amount of time, and it will give me some output. Now that that's done, I can actually switch back to the console and see the results of that deployment. So here we can see our webinar container service is currently being deployed, and we can see the same information that was provided in that containers configuration file here. I've got 2 containers, the Flask container or the app container listening on port 5000. I have the Nginx container or web container listening on port 80. I've also provided some environmental variables that let it know how to reach the Flask container and send requests to it. It's going to do that on localhost and port 5000. I also have set up a public endpoint, in this case port 80 again, so all requests will be forwarded to the Nginx container, which will then forward those requests back to the Flask container. So pretty straightforward. Now to test this, I'm going to go to the public domain for this container service. It's not completed deploying yet, so I'm going to go back to one of the container services that I created previously. And as you can see here, it's configured the same way. I'm going to go to the public domain and open that up. As you can see here, it's showing the text that indicates it is going through Nginx and back to the Flask service. One of the things that I haven't shown yet, but that you can do, I mentioned previously, is at any time after a service has been created and deployed, you can go in and change the capacity of that service. As I mentioned, you may want to do this simply as your capacity needs grow or in response to a particular event. I can go into the container service, choose capacity, choose to change that capacity, and I can choose again the power and the scale of my container service. And when I apply that, the Lightsail container service will create those new nodes, deploy them, and then transfer traffic over to them. On this screen, you can also see images that were created for this particular container service. As I mentioned before, these containers that aren't currently in use, I can go in and I can delete them and clean up after myself when those are no longer needed. If I want to look at metrics for the container service, I can do that. And I can look at CPU utilization or memory utilization for this particular container service. And if I need to, I can set up a custom domain for this container service. So instead of going to this public domain, I could go to a custom domain that I've already previously configured. So with that, I'll switch back to the presentation. We finished up the demonstrations. We've walked through creating a container service, deploying a public container, deploying your own container, and then deploying multiple containers. And I hope you've seen how easy and straightforward it is to do that. I'd like to close with some advice on how to choose when to use Lightsail containers versus other container services on AWS like EKS or ECS or Fargate or Beanstalk, for example. When should you use Lightsail containers? Lightsail containers is great when you want to learn about containers in the cloud. So for example, you're a student and you're learning about containers, you're a new developer and you want to know more about cloud containers, or you're a hobbyist building things in containers in the cloud. If you want to gain experience running containers in the cloud, Lightsail containers is a great choice. If you have little experience running containers or dealing with orchestration, or maybe you're an experienced container administrator and understand the ins and outs of orchestration, but you have a simple application and you really just need a simple solution without a lot of configuration options, then Lightsail Containers is for you. You should use Elastic Kubernetes Service or Elastic Container Service, Fargate, or Beanstalk if you need advanced orchestration or you need features like Service Mesh, for example. Then you should use one of the other more full-featured services. Also, if you have specific compute needs, like you have very specific CPU or RAM combination needs for your container applications, or you require GPUs or need auto scaling, for example. Also, if you have advanced networking needs or you need access to security controls, then you should choose EKS or ECS or one of the other services. Or finally, if you need more granular access to the underlying resources, then those other services are a better fit for your application. So I hope that was a good intro for you to both Lightsail and to Lightsail Containers. I think with the information that you've seen today, you can see how easy it is and how quickly you can get started with Lightsail Containers. I think you should be able to do that very quickly. With that, now it's time to answer some of your questions. So I will move into Q&A time and invite you to ask any questions, and I'll try to provide answers as I can. Thank you.